I guess that in this conference I don't need to motivate much what I mean by fiscal volatility shocks. What I'm going to do in this paper is to look at the effects of increases in the uncertainty about future fiscal policy. And in particular, I'm going to be interested in A, measuring them in the data, and B, looking at their effects through the lenses of a standard business cycle model. This is joint work, before I continue, with Pablo Guerrón Quintana from the Philadelphia Fed, Keith Quester, who just moved to Bond University, and Juan Rubio Ramirez, who claims he's affiliated with Duke. And the motivation for this paper is very straightforward, and it was motivated by conversations that Pablo, Keith, Juan, and I were having while visiting the Philadelphia Fed about the effects of fiscal policy uncertainty. In particular, we were motivated by this type of questions, like this statement by Ben Bernanke, where he claims that uncertainty about fiscal policy in the future is actually a headwind for recovery and has real effects. And in particular, Charlie Plosser, who is the president of the Philadelphia Fed, is a very strong supporter of that view. So what we wanted to do was, as I was saying before, one, is this true? And second, can we find evidence of that in the data? So what we are going to do in this paper is divided basically in two parts. First, we are going to go to the data, and we are going to estimate stochastic processes for fiscal policy in the US. You will see that our approach is going to be different from Nick and Steve and Scott's approach, in the sense that we are going to use a fully specified parametric model. And I will try to point out the good and the bad things about that, because of course there are important trade-offs. And what we are going to try to document, I think the likelihood function really screams for the importance of these fiscal volatility shocks. There is overwhelming evidence in the data that the volatility of fiscal policy changes over time. And then what we are going to say is, well, let's build an otherwise standard equilibrium business cycle model, and let's hit this equilibrium business cycle model with one of these fiscal volatility shocks of the size that we have documented in the data. And we are going to look at what happens after that. For those of you who are interested in a little bit more methodological issues, this is a super interesting problem, because both the estimation and the computation of the model are inherently non-linear processes, because volatility is about second moments, not about first moments. So you are forced to work a little bit harder than just doing a simple linearization. But I will not, given that, as I was saying, it's Friday 8:30, I will not get much into long asymptotic expansions. The main results, in case I don't get to the end of the talk with enough time, are as follows. First, as I was saying before, we are going to estimate fiscal processes for fiscal instruments, in particular for the tax on capital income, the tax on labor income, the tax on consumption, and government expenditure. And we are going to find very strong amount of this time-varying volatility, as I was referring before. In the model, the consequence of one of these fiscal volatility shocks is going to be a drop in output, a drop in hours, a drop in consumption, a drop in investment, and it's actually going to be a drop that is going to last for several quarters. In addition to it, the main mechanism is not going to be the only mechanism, but the main mechanism behind this is going to be extremely transparent. And if you understand this very simple idea, you actually understood most of the paper. So imagine that I'm a monopolist, competitive monopolist, and I need to set my price one period in advance. So I need to set my price January the 1st for the incoming year, before I see the prices, the realization of other shocks in the economy. With a standard Dixit-Stiglitz aggregator function, but for the matter, for many other aggregators of different type of goods in a monopolistic competition setup, the profit function is going to be asymmetric. What is this? What you're trying to do is trying to get that the relative price of your good is 1. I'm going to normalize the optimal relative price to 1. If you miss over here, that is, your price is a little bit too low, you are going to lose much more in terms of profit than you miss on the other side. And the idea is very simple. You just do the math and you will see that this has this shape, and it's because you are selling a lot at a very low margin. That's very bad for you. On the other side, you are selling much less but at a very good margin. Imagine now that, as I was saying before, you cannot really target one with probability 1 because there is going to be uncertainty. So really the distribution of events that can happen tomorrow is going to be given by some distribution. Since this loss function, this profit function is asymmetric, you are going to bias a little bit towards the right. So instead of aiming for 1 on expectation, you are going to aim for 1.05, let's say, on expectation. We are going to call this the upward pricing bias induced by uncertainty. Now, let's imagine that we have a shock to uncertainty, which can come from the fiscal volatility shock. By the way, this theoretical argument is much more general. It can really come from any other part of the economy. Then your distribution is going to be more dispersed, which means that you are not going to target 1.05, you may target, let's say, 1.1. That's equivalent to an endogenous increase in the markups. So higher volatility means that there is going to be more precautionary pricing, let me use that word. Higher markup, we know that in the standard equilibrium business cycle models, works exactly as a tax on consumption. So in some sense, an increase in the variance works like a tax on consumption, an increase in the tax on consumption, and that's exactly the results that you get. You know, this is what we teach first-year graduate students when you have this increase in the tax on consumption. Yes?
Actually, the other side of the high markup coin, low real wage, I guess that's what you just said.
Yeah, and that's exactly just another way. It's exactly the other way to think about it, except, you know, W divided by P. I'm thinking about P, you're thinking about like the whole thing, but it's the same.
But then in terms of empirical work, I'm going back to this issue of whether real wages are pro-cyclical or counter-cyclical, and that sort of thing.
Yes. Okay, so it's a little bit tricky because when we go to the data, all my statements are conditional on that particular shock. While usually when people talk about the cyclicality or contra-cyclicality of real wages, they are talking about the unconditional moment, or like after all type of business cycle models. So if I wanted to document that in the data, I will need to go to the data, identify these fiscal volatility shocks, and look what happens with real wages after that fiscal volatility shock. And we haven't undertaken that, so it's hard for me to say much more. Okay? But I will actually try to argue that there are some things in the data over the last 3 or 4 years that point out that this may not be a totally crazy assumption about the world. Yes?
It's kind of related. So, I mean, you're not going to have idiosyncratic shocks in your model, I suppose, right? But
I'm not going to have, excuse me?
Idiosyncratic shocks
No.
at the firm level.
Yes.
We know that there is a lot of
Yes.
volatility at the firm level.
Yes.
Which, you know, it's probably an order of magnitude bigger than, say, aggregate uncertainty. So this mechanism suggests that changes in idiosyncratic uncertainty should have like a huge effect.
Yes.
On output.
Yes. Yes. I know.
Quantitatively.
I know. And in fact, yes. And in fact, if you, it's kind of interesting that you asked that. That was something that came to our mind right after we finished this paper, and we gathered the troops, and we are actually trying to compute a gigantic model with heterogeneity with firms. And you know, there is a computer in some place in Spain generating a lot of CO2 doing that right now.
But just when you looked at the sort of models that they do that, maybe actually with a big pencil, no? With
Yes.
they don't really find that asymmetry even in the. So you solve this model.
Yes.
You
So
solve
the
the quadratic, you solve
yeah.
the cubic, you get essentially the same SF band.
Yes. No, but
Except the one is more shaded to the left
Yeah.
than to the right.
No, but we are doing something slightly. Let me not. We can talk about that later at the coffee break because it will take me away. But we are doing it in a slightly different way than in the literature, precisely because of that. It kind of links to all the discussion of Kahn and Thomas and all those type of papers. But let me not get out from the main. Yes. I think it's quite general. I think it's really a mechanism that is out there for a very large class of aggregators. Kimball has a paper in Economic Letters in 1986 where he points that out, and he gives sufficient conditions for it to happen, and they are relatively general.
Is the basic intuition price is too low, your volume is very big.
Yep.
Therefore, your mistake scaled up.
Yep.
Big volume.
Yep.
Price is too high, your volume.
Exactly. And in fact, it's also very interesting because Boll and Romer have a review of economic studies in 1989, where they also talk about the first order effect of second order mistakes in pricing, and they have a formula where it's not time-varying volatility, it's just the standard deviation, which they take as a fixed parameter. But you can see very well, if you think about that formula through that lenses, they are saying the same, it's just that they are not verbalizing in the text. But we are getting the same result in some sense.
Maybe we'll go through it. The other thing you often see in these production models is this half-enable effect, whereby you like variance, gives good shocks, you can expand it, taking bad shocks.
Yeah.
It's kind of the flip side of it.
Exactly. And it's because of these nominal rigidities in the time you set up your pricing. Yeah. Exactly. Now, the question is, how big is this? We document this fact, how big it is. Well, it's going to be relatively important. It's not going to be huge. I want to be, honest about it. But I think it's actually significant. So we measure that a 2 standard deviation fiscal volatility shock. Note that I say 2 standard, and that's something that after Nick I think has become pretty common in the literature. The idea basically is that I'm not interested in 2004 third quarter, a little bit of an increase in fiscal uncertainty. I'm thinking about stuff that happen every 10, 15 years where there is really a lot of fiscal uncertainty. Has an effect that is going to be similar to 30 basis point innovation in the federal funds rate as estimated by a structural vector autoregression. So remember, this is not a change in 30 basis points of the federal funds rate. It's a change of 30 basis points with respect to what the Taylor rule is telling you should be doing. Okay? And you say, is this big or small? Well, 30 basis points is roughly the standard deviation of a monetary policy shock in the US after World War II. So if you believe that all the papers out there and the small industry of papers out there doing monetary policy business cycle models are interested and have something to say, you should also believe that this number is big enough. Yes?
So is it sort of okay to think about something like a variance decomposition of this type of model gives you something on the other process?
Yeah. Okay, so it's quite difficult to do variance decomposition because of the nonlinear effects. Okay, because you cannot really do that. But yes, if you want to think about this as giving you between 15 to 20%, that's a right order of magnitude if you accept Venus.
And your shocks have been soft.
Yes.
So it should be small then.
Oh, I see what you mean. I see what you mean. We haven't really done this variance decomposition, so I was using the intuition from monetary policy. But we didn't do the variance decomposition because this is not linear. Okay, there is actually a case where these fiscal volatility shocks may be much bigger. And I'm not going to claim this is the situation we are now. This is just food for thought, which is the following. The fiscal processes that we are going to estimate are going to have feedback effects. What do I mean by that? There is something, you want to call it automatic stabilizers, fine. I just want to think about it as the systematic responses in the data of fiscal policy to the variations of output. Okay? It can be just because built-in automatic stabilizers in the code, in the tax code, but it can be just the average response of Congress. So if Congress, every time there is a recession, does something, we are going to control that as the average response. Well, when you have a fiscal volatility shock, that has a contractionary effect on the economy because of that endogenous increase in the markup. Well, then this systematic response of fiscal policy is going to kick in and is going to smooth that response. Okay, so you are going to have a small decrease in taxes and a small increase in government consumption. That undoes much of the variation that we get. So let's say for a moment that, for whatever the reason, that systematic response of the automatic stabilizer has been shut down. Then you get a much, much bigger effect, as big as 300 basis points. So what we are trying to say is, if fiscal policy responds in historical ways, this is important but not homologous. If for whatever the reason fiscal policy is short-circuited, then it can really be very, very large. Also, something very interesting is that fiscal volatility shocks are going to be stagflationary. Why? Because you are having this increase in the markups. So on one hand, you have the increase in the price level or the reduction in the real wages and a reduction in output. So if you are a very naive person that writes columns in the New York Times, you will say it's just completely random event. If you are a naive person, you will say, wow, I cannot understand this. Why? Because it doesn't look like a demand shock where you should see prices going down, and it doesn't look like a supply shock either because the marginal cost in this economy is going to be going down. And you are going to say, how can this be? And the reason why I think this is actually interesting is because if you go back to 2008 and early 2009, the Fed was very, very worried of the US economy entering into a deflation. And yet it didn't happen. We didn't have inflation, but we didn't really get much into a deflation. So maybe the reason we didn't deflate as much as people fear was because some of these other shocks, these increases in the markups. And in fact, if you go to the data, there is some telltale evidence, it's preliminary evidence, but there is some evidence that firms are really having high margins right now, high markups. Okay? And then finally, I already talked about 7. Finally, since at the end of the day, the Fed was paying for a lot of this work, we needed to say something about monetary policy. Interestingly enough, the Fed wants to be tough. Okay? So the optimal, well, we are not going to do a full Ramsey approach, but so let me be a little bit loose over there. If the Fed is tough in the sense of responding very aggressively to inflation in this model, agents know that the exposed dispersion of the price level, of the relative price that they are going to have, is going to be less dispersed. It's going to be more concentrated. So they are going to respond by biasing their price decision less. If the Fed is very accommodative, for instance, to output gap, then really a lot of things can happen. There is going to be a lot of dispersion in the relative price, and then firms are going to respond with high markups. So in this model, it's easy to see that you actually get higher welfare when the Fed is actually very aggressive. So higher fiscal volatility is not an argument for the Fed to be accommodative. It's actually an argument for the Fed to be tough. Yes?
I guess one thing that looks very interesting from this is that, I don't know if Joe has access to this again, maybe you have to go, but like Barbara's type of work, I mean, he could actually look at the price changes at the individual firm, measure at different times. So he actually has some statistics about the frequency and the price changes, because you actually
I see what you mean.
Really clear predictions at the firm level.
No, that's a very good point. We should really try to think about all those in the micro data. Anyway, so let me tell you about the first part of the paper, which is how do we measure these fiscal volatility shocks. Well, I guess that I don't need to convince you that volatility is not directly observed, that you actually need to work a little bit harder. What we are going to do is to estimate what is known, especially in financial econometrics, and a stochastic volatility process, which is the following. First, I'm going to tell you what the process is so you understand, and then I'm going to tell you the good things and the bad things about this. Well, you take, I don't know, government expenditure, and you say, well, you go to the data, and a good way to think about it is as an autoregressive component, always a simple first tricky time series. Then government expenditure can also respond to, for instance, a measure of the deviation of output with respect to trend, and this is the systematic response I was mentioning before. It may also respond to debt over GDP ratio, and it may respond to many other controls. We actually, in the paper we get into a lot of discussion about what you should and not should put over there. This is kind of a simple plain vanilla. Okay? So the idea is you are going to have some ARMA component, and you are going to have some control component. And then you are going to have innovations, and these innovations are going to have some standard deviation, and this standard deviation is going to have a t. Okay? So if you forget about this t, this is the type of fiscal policy rules that people have estimated in the 90s. There are like 10 quintillion papers about them. Okay? Okay, so what we add is this t, this innovation. And what we are going to, this innovation, time varying volatility. And this time varying volatility, we are going to assume it follows itself an autoregressive process. Of course, that over there is to an exponent, over here is in levels. You want to ensure that the standard deviations are positive, kind of a useful property. And you are going to have innovations to volatility. So over here you are going to have the shock to volatility that changes the level of the volatility, and over there you are going to have the shock to the level, or the innovation to the level. So it's very clear the great advantage of this very strongly parametric process is that it's very obvious what is a shock to the first level and what is a shock to the second level. Okay? And remember, we are not going to just look at the government consumption and say, oh, government consumption changes, that's a change in the innovation. No, it's a change with respect to what the rule is telling you it should happen. Another great thing about this type of a structure is that it's very easy to put it inside a model. Because you can say, look, agents know that the fiscal policy follow this stochastic process. They just build rational expectations about it, and they behave like that. What is the bad thing about this? Well, it's forcing me to buy a very tight parametric structure. And who knows, is this a good representation of the data or not? If I were in the audience and I would like to give me a hard time, the first question I will ask myself will be, are those parameters stable over time? Is it the case that the Republican Party feels about debt over GDP ratio the same way it felt in the 1960s? And probably the answer is no. Or maybe the thing is that there is some type of a structural change that is just starting to happen with respect to the future. All those type of things, we need to accept them through the lenses only of this type of thing. Maybe we could estimate more complicated processes, allowing for time-varying parameters as well, while the great advantage of Nick, Steven, and Scott is that it's much more non-parametric, if I can call it in that way, if you let me. So in that sense, they don't need to buy all these extra assumptions. Okay? So I think that there is something good about both ways to think about the world and, being a little bit pragmatic. Now, we are not going to fight the war of building taxes on income, on capital. There is, a whole subset of people and a whole set of conferences out there that do those things and have their fights. I happen to like Enrique Mendoza. I happen to like the stuff that he does and that Lipper has done. So we are just going to say, hey, we are going to take their data and we are going to estimate that process from 1970 to 2010. Again, as I was saying before, this is 9 in the morning, so I'm not going to bore you with all these boring details. The only thing you need to take away is that this is actually a little bit complicated because you have those nonlinearities, so you cannot evaluate the likelihood function directly. You need to do something a little bit harder. You need to use something that is called a particle filter, which is basically a sequential Monte Carlo method. And then you are going to draw from the posterior. We are going to use flat priors, so don't worry about the priors. And you are going to draw from the posterior of this process using a Markov chain Monte Carlo. And we do all the technical things that you're supposed to do to be sure that this actually works fine. Okay. Now, since we have a fully parametric structure, we can go and smooth the fiscal volatility in the data. Yes?
Government spending, you mean government consumption?
Yes, government consumption. Sorry about that. So we can go to the data and we can smooth out the implied realized volatility. By that I mean, when you are doing this filtering, the filtering is passing forward and smoothing is going back. So we also do the going back. And then you can look at this. Don't worry too much about the numbers. I'm going to have in the very next slide, I will give you something you can relate to as an economist. The only thing I want to mention is look at the capital tax, how the capital, the volatility that we estimate of the capital tax increases very consistently around the shaded areas of the MVR recessions. But even outside that, sometimes it spikes. So it seems to be a lot, really a lot of evidence of this volatility changes over time. And in fact, if you look at the likelihood increases a lot when you let this extra degree of freedom of having time-varying volatility.
In practice, it will estimate those spikes when it changes.
Yes. Yeah. Now, I just skip very quickly a table with a lot of numbers. Those are the estimates, blah, 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 blah. Again, in the director's cut version of the presentation, I could spend more time on it. But let me show you how this will work in real life. So imagine that you are, Perotti or some of these guys estimating fiscal policy rules standard style with constant volatility. And I ask you, estimate what the confidence band is going to be for the tax on capital income over the next 40 quarters. You are going to start at the mean, of course, 37%, and what you are going to see is this blue confidence band. So you are going to say, look, I can be between 0.34 or 0.42, but the variation, most of the mass of the variation is going to be over here. Now, let's suppose that now we are in a world where there is a stochastic volatility, but today we didn't get any stochastic volatility shock. So today is normal times. Now, what you think it can happen tomorrow is this black line. How do you read this black line? Well, it's basically saying I start at 0.37, I start at average volatility, but I know that down the road I can get a volatility shock. So much more dispersed things can happen. Finally, the third line, the red line, is when you not only have a stochastic volatility, but today you got a stochastic volatility shock. That means that today I'm telling you that tomorrow is going to be very uncertain. And you can see this extra mass over here, this extra area of this extra amount of uncertainty you have about the future. This is the effect of my beliefs about future tax rates implied by a volatility shock. Okay? And you can see that this is a non-trivial amount, especially on capital tax on income and income on tax on capital income, and we know that models respond a lot to that.
These axes are volatility vertical?
No, this is the tax rate. Okay, this is the average tax rate. This in the data is 0.37, and I'm asking you, what do you think is going to be the average tax rate tomorrow?
The previous slide, the axis was the volatility.
Yeah, and the previous slide it was the volatility. It's just so in some sense what this thing is doing is putting over here in terms of rates.
The government spending just happens to have volatility.
Yes, government spending in our data. Yeah.
More or less the same.
Yeah.
When you go from the blue line to the black line, you just take your stochastic volatility model and turn off the volatility?
Yes, turn off you.
Another model.
Exactly, but the thing is, I turn off the volatility, the realization of the volatility today, but with respect to tomorrow, I'm trying to figure out what can happen tomorrow. I take account that tomorrow I can have a shock.
The blue line.
Yes.
Simply when it's well,
Oh, yeah. The blue line will be to set this to zero, to the mean in the data.
Okay, but you estimating it.
Yes, that I missed. Yeah.
So it's not quite what they did.
Yeah, exactly. It's not exactly the same, but it doesn't. We actually did it in the other way around also, and it doesn't really matter. Because this thing is going to force this to have the same. It's not going to be exactly the same mean because of the small sample, but it's pretty much the same thing. Okay. So now, how this compares with other measures? Okay. So I don't know if Nick remembers, but we presented this at Stanford 1 year ago, and he said, "Oh, look, I have my index, or the version of the index back then in September 2011. So we went up to his office right away. He opened a Stata, and we ran the two things, one against the other. We were quite surprised that the correlation was surprisingly high. I'm reporting over here the correlation of uncertainty with capital taxes, because I will argue later that capital taxes is really the most important component, is 0.43. I remember that the tax on consumption was 0.69, 0.7, and if you just plot one index on top of the other, they really look very similar. And we were very surprised because, this is completely different empirical approaches. They have a small army of undergrads reading the collect works of all the newspapers ever written, and we just have a particle filter doing Markov chain Monte Carlos. And, the fact that you get 0.44 correlation to me is very, very compelling evidence that we seem to be capturing something important. And, given the amount of noise in all these type of things, is, to tell you the truth, if I had a higher number, I would suspect something was wrong. So there is a Laffer curve on how good your empirical results can be. Yeah.
So about the measurement. So let's say you look at around 1986, right?
Yes.
And let's say basically both Nick et al. Measure would spike up, and yours also goes up because there was this change in taxes, for example. Right, but we kind of know that 1986 was a Republican administration.
Yes.
So there is some uncertainty as to the future, saying capital tax or income tax, but we know also they're going to go down.
Yes.
Instead, you're because the symmetry that you impose.
Yeah. So two things with respect to that. First thing, there is a big shortcoming in all these measures of uncertainty that I think we hinted at yesterday, which is we don't know the beliefs in the heads of people. In some sense, the only thing that we are measuring at least in my case, is realized volatility. And I'm making the jump of saying realized volatility is really what people have in their heads. Maybe Nick and Stephen and Scott, since they have newspapers, that's a better measure of what is in the heads of people. So I give you that point that this is an important shortcoming. Second, the second issue is very important, which is all the papers that we are discussing these days are two-sided risk. You can have very, very bad realizations, but high volatility also means very, very good realizations. Now, this sounds bad. This sounds bad because, if you ask me about what is the future of Spain, I will tell you there are two things that can happen: a bad realization or a really bad realization. Okay? So I'm going to call that one-sided risk. And I think I have a slide at the end where we talk about it. That was, for us, one of the main shortcomings of this approach, and we are actually currently working on that. We are spending really a lot of time. We have discovered a very flexible set of distributions that allow you to get shocks to skewness, and we are trying to figure it out how to compute the models with shock to skewness. Okay? So, but you are completely right, that's a very important problem.
It's amazing, I think, Sarah, in the sense that
Yeah.
I presume under the political process, if you see taxes go up, it's probably been discussed in advance. I mean, so right now there hasn't been a big change, but assuming there probably will be a big change in taxes,
Yeah.
the uncertainty happens in advance.
Yes,
But
and
it's well signaled because politicians are discussing
Yeah.
this in the news.
Yeah.
And therefore, the way you smooth, I think, you smooth it back.
Yeah, exactly, because you are using the whole data sample in some sense. Well, not in some sense, that's what a smoothie literal is. Yeah.
The jump happens next period.
Yeah, no, but
Some uncertainty now.
yeah, but one very, very nice comment I hear yesterday, and I apologize if the person is here and I, yeah.
But these Garch things,
Yes.
they only happens ex post.
Yes, exactly. And the guards, and remember that the thing we are not big fans of guards always is because it's very difficult to distinguish with what is a shock to the first moment and to the second moment, because the innovation in the second moment is an autoregressive of the innovation in the first moment. So it's very difficult to really distinguish that. And also, let me just depart for 30 seconds. If you think about the history of econometrics, actually stochastic volatility processes were proposed earlier at the beginning of the 70s. And people say, oh, this looks great, this is probably the way to go. Given the computational power we have at the early 70s, we couldn't really do them. And the brilliance of Engel was to figure it out that the GARCH was kind of a shortcut that will get most of what the stochastic volatility models do, and you could actually do it in the computer of 1982. But now that we don't need to do that, if you are a practitioner in Wall Street, maybe it doesn't really matter that much, but I think that, if we are researchers, we should really, be at the frontier of the technology. Okay, so that's a little bit for the empirical part. Now let me do the second part of the paper, which is, as I was saying before, yes, I hit this equilibrium model with these changes in the volatility. The model is going to be very, very straightforward, so I'm not even going to present the equations. It's going to be a representative household. That goes a little bit to the questions both of Fernando and Gianluca. Look, maybe you are missing a lot of things because you have an heterogeneous agent model. Completely happy with that. My job market paper was from heterogeneous agent models. I love heterogeneous agent models. I just wanted to see first what happens in a rep agent model. We are going to have labor supply that is flexible, but we are going to have sticky wages, and we are also going to have sticky prices. Note that I'm going to have quadratic adjustment cost and not Taylor. The reason for that is as follows. When you're doing a linear approximation and the target inflation of the monetary authority is 0, quadratic and Taylor are the same. When you, do not have average inflation or target inflation 0, and you are not doing a linear solution, then both assumptions are different. In particular, Taylor is going to imply a distribution, a non-degenerate distribution of prices, and shocks to volatility are going to change that distribution of prices. I don't know how to interpret that distribution of prices. So I thought it would be better to do quadratic, because in quadratic it's going to be much more transparent what is going on without that changes in the distribution of prices. Fear not, we also computed the model with Calvo. So we did, with Taylor. We did with Calvo. We did also with Calvo prices. So we did both. I'm just reporting quadratic to avoid that problem of changing distributions. And the fiscal rules as discussed above, and then a very standard Taylor rule for monetary policy. The only thing I need to ensure is I need to be sure that the government budget constraint is satisfied. We are going to do that with transfers. If you note, I didn't estimate transfers as a separate process. And the reason I'm going to do that is I'm going to say that transfers, this is kind of a standard trick in the literature. I could do it in other ways, so it's not I don't think it's a big deal. So if you don't like it, I will be happy to change it, which is basically some mean and then some deviation of, and there should be an output over here, of the debt over GDP output versus some type of target. And the idea is that when debt over GDP deviates from the target, by a little bit, just by a very, very small number, I revert back. I lower my transfers a little bit, and that ensures stability in the long run. But I'm going to pick a really, really small number, like 0.001. So this, in the short run, in the first 40 quarters, is not going to have any effect. That's just to ensure stability. Okay. Now, the definition of equilibrium is, of course, absolutely standard. I need to use a third order perturbation. Why? Remember, first order, certainty equivalent. I cannot do anything about changes in volatility. Second order, you are going to have shocks to volatility in the solution, but we have another paper where we prove a theorem that says that in second order approximations, the shock to the innovation in volatility only appears multiplied by the shock to the innovation in the level. And that's bad because it doesn't allow you to compute an impulse response function, because impulse response functions are about partial derivatives. You only want to have the one of the shocks at the same time, so we do a third order. In addition to it, a standard Euler equation error analysis tells you that third order components are important. If any of you cares to ask about it, we also compute it up to 10th order. It doesn't really matter after third order. Okay, calibration. I'm not going to get into the calibration in detail. I only want to mention one thing that is important to know about these models. When you have nonlinear solution methods, you don't want to calibrate in the standard Kirtland-Prescott way. So Kirtland-Prescott say, look at the steady state of the economy, and let me pick parameter values such that the mean in the data is equal to the steady state in the model. Well, that works because in the first order approximation, the ergodic distribution of states is centered around the steady state. But when you have second and third order effects, the ergodic distribution of states is not centered around the steady state. You have all the second and third order components. So what you want to do is to match the distributions implied by the model with the distributions implied by the data, or the distributions observed in the data. So the calibration requires a little bit more effort. But, let's suppose we did that. And then, finally, we go to the model and we say, let's hit the model with these two standard deviation volatility shock I mentioned before, and let's see what happens. Okay, so, sorry.
Government consumption, is that like defense or?
Yeah, so government consumption is going to be, defense. I think Medicare is considered consumption or transfers. I'm not sure now.
It depends on the time period you're looking at, but
yeah.
Medicare and public schooling and those sorts of things, I would think you would want to put as some kind of substitutes in the utility function for private consumption.
Fair enough.
Yeah.
Implicitly we are assuming they are separable, but yes, that's a very good point. That's a very good point. I just didn't think about it, and we could do it. Yes.
What is the type of shock that will make you affect directly the prices? A shock that will, G will be kind of something you want to produce more. So can you have like taxes?
Yes, and in addition to it, I have shocks to productivity. I have shocks to the.
Which is the one that you think you will be kind of hard, like in the picture you have?
Oh, okay, something like that. Any type of shock, for instance, to the level, any type of shock to fiscal policy will change a lot, for instance, your labor supply. And by changing the labor supply, it's going to change your marginal cost. So it's going to change where you would like to be on this distribution. Yeah, government purchase. No, but it can be also a tax on labor income. So a shock to the tax on labor income will affect your marginal cost through labor supply. Or a shock to productivity. We have shocks to productivity. We have investment-specific technological shocks. We have the whole set of standard shocks in these business cycle models. And all those are the ones who are going to have an effect on this. Okay, the impulse response function. So as you can see over here, output goes down and then it recovers. Now, investment also goes down, so most of the contraction is through investment. Hours go down, oh, this is beautiful. Consumption goes down. Okay? And the reason why this is beautiful is because in many of these type of models, that like the ones we saw yesterday, when you want to wait and see what happens, well, if you are still producing output, you need to do something with it. You need to eat it. So in a lot of these models, you tend to find that consumption goes up, which is not what the type of VRs that Nick documents find. Why is consumption going down over here? Because the extra distortion generated by this higher markup is in some sense making us less productive, so we have less stuff. So even if we reduce investment a lot, we still don't have enough things to eat, and we reduce consumption. And marginal cost goes down, but inflation goes up. This is the stagflationary effect I was telling you because of this effect over here. And this is what I will telling you that, if you were doing a very simple Phillips curve and you had some data of the marginal cost, you will be really puzzled. This thing is going down, inflation is going up, how can it be? Well, it is through the decisions of agents in the economy. And you can see that wages are also going down, the real wages, which is precisely. These are percentages. So you are having like a 1% fall up to a 2%.
Why do hours go down 7 times when wages do?
Let me look at the freeze elasticity. Okay.
I was expecting, I saw your freeze elasticity
It's,
at half.
yeah, it's.
It would go down about half.
No, it's 2. It's not half. We are like writing 1 over the thing. So it's 2. It's relatively high. Yeah, I don't know. I don't really know, sorry. I didn't notice it before. Okay, let me come back to you. I'll ask, I'll rerun this thing and I'll tell you.
How much of your labor supply?
So we are using, well,
Your labor supply at all?
yeah, so we have the problem over here is a little bit tricky because you have sticky waves. So it's a little bit harder for me to do that's why I'm reluctant to say anything on the top of my head. I really need to sit down and do the decomposition. Now, let me put in red the impulse response functions that you get from a very standard structural vector autoregression. This is the one by Altic, Cristiano, Eichenbaum, and Linde. And this is the response to a one standard deviation innovation to monetary policy. And that's the type of argument I was telling you. The responses are very similar in size for output, a little bit less for consumption, but also very similar for investment, for the nominal interest rate, but not for inflation. So basically, we know that after one of these monetary policy shocks, it's very difficult to tell what happens with inflation in the short run, in the first quarters, while we very clearly have this stagflationary effect I was mentioning before. Well, this is just the same graph as before, so I don't need to go over this. Now, how important is this precautionary price setting mechanism? Something I can do, because there is going to be a second mechanism that I'm not emphasizing enough, perhaps, which is just the standard precautionary saving behavior of households. There is more uncertainty about the future, so I just want to consume less, and I want to be more careful about the future. So what we do is the following. We say, let's go to the problem of the firm, and let's look at the decision rule of the firm with respect to prices. And let's shut down at the decision rule of the firm the terms that involve non-linear components. So the firm is like operating in a linear wall. But the rest of the economy is still the non-linear economy. And so the black line is the one I had before. The blue line is the one on this, counterfactual economy or alternative economy. You can see that the reduction in output fall is like 50%. But where you are really, really going to see the big difference is in inflation. Now, of course, you don't have any effect on inflation in the short run because firms are not responding to it. And what you have is a reduction in inflation in the middle run, triggered just by the fact that there is less demand. And firms, when they have the chance to readjust prices, they are going to lower it a little bit to compensate for the lower demand.
You get, so this is when you remove the precautionary price setting, it's all on precautionary savings.
Yes.
But in these models, I guess I've seen this problem that C plus I equals Y. So
Yeah.
you want to save more, but it has to go somewhere. And that
Yes. Exactly. So what is going to happen also is that,
You have to have output.
yes, this is going to matter. the way this is going to work is because the price rigidities, you are having this fall in demand, and firms are ready to supply whatever they are asked at that price. Yeah, this is with price rigidity. So the price.
Like the Bassi funding thing.
Yeah, something exactly.
Perfect. You fix prices.
Yeah.
With short
Yeah.
cycle.
Yeah, exactly. So if I didn't have any price rigidity, that mechanism you are mentioning works nearly perfectly. It doesn't work 100%, but you get 90% there, which is yes, I want to consume less, but on the other hand, I want to work harder, and one thing compensates with the other. Okay. This is the case where I shut down this automatic stabilizer or systematic responses of fiscal policy. So black line is the same as before, except that now I'm changing the size. The red line is when there is no response of the fiscal instruments to output, to deviations of output with respect to the trend. And the blue is when there are no responses either to output or to debt. And you see exactly what I was mentioning in the introduction, that once you are not correcting for the increase or for the fall in output triggered by the increase in fiscal volatility, then the effects are much, much bigger. Is this the situation we are now? I'm not going to go there. I'm just saying, this is something maybe we can think more carefully about it. Another exercise we do is we decompose the effects of each of the different fiscal volatility shocks. Nearly everything is through the shock on the volatility of the tax on capital income. Why? Because at the end of the day, these equilibrium business cycle models with sticky prices and sticky wages is just a real business cycle model. It's just a real business cycle model. We have a sprinkle, a little bit of nominal rigidity in the short run. So at the end of the day, we know that Cham-Liyad wants to reasset itself. Anything you do to screw up the tax on capital income is going to come and hit you big time. So of course it's going to be through capital. So that's not a big thing. And this is the effect for monetary policy. How many minutes I have? Okay, perfect. I'm doing perfect in time. So, again, we didn't have time to do a full Ramsey analysis. Actually, I think that that's something that is really interesting to do, a Ramsey analysis when you have volatility shocks. What we did was something much, much simpler. So again, the black line is the benchmark case. And let me show you in red what will happen if the monetary authority, instead of responding with 1.25 to deviations of inflation with respect to the target, is tougher, is 1.5. And that's the red line. And you can see that output gets reduced, the fall in output gets reduced, and it's precisely because of the mechanism I was mentioning. You have less uncertainty about the future, where your relative price will be, because you know that the monetary authority has a much tougher stand against exposed deviations of inflation. When I lower, let me go back then to 1.25 over here, but now let me increase the response to output gap from 0.25 to 0.5, and then you get this blue one, and you can see it's bigger. So by trying to accommodate more deviations of the output gap, you're actually making things worse. So this is a paper that says, yeah, there may be a lot of fiscal uncertainty out there. The Fed needs to keep its calm and still be tough against inflation.
So this is
Yes.
in fact, Ben's job market paper, if you had zero low,
Okay. I forecasted what you were going to get over there. Okay. Now, things that we don't have. We don't have financial frictions. Okay? So anything where, financial frictions, fiscal volatility, fiscal volatility may affect, how much you can borrow, your collateral constraints, all those things. I think they are very important. I love these models with financial frictions. We are not quite there yet. Okay? So it will be interesting to see how they interact.
essentially though, on stuff, if you have zero low bound, you can't do anything.
Yeah.
It makes it more
Exactly. So that's the point over here. We didn't try to address the zero lower bound explicitly. We have kind of maybe half a page where we talk a little bit. We didn't know your paper until Martin told us. It's very interesting. I think there is a lot of stuff about the zero lower bound, and your paper has a lot of nice points. I think there is even more nice points over there to be discussed. The only good thing, and this is kind of a paradoxical result, the zero lower bound is very bad because everyone will like to lower their prices, but they cannot, okay, because of rigidities. This is a model where this shock to uncertainty means that you don't want to lower them as much because you actually want to increase them. So surprisingly enough, you can actually have an effect on the opposite direction. So that's why I was saying there is a lot of things to be explored there. I'm not 100% sure how to say. Non-convexities, your paper and many other papers that we saw yesterday about adjustment costs, etc. We don't really have any of those things. All the micro heterogeneity I was mentioning. Also, something I'm very interested. This is a model that works through investment. Well, there is a very particular type of investment that after 10 years at Penn has been hammered into my head, which is labor relations, search and matching. So if you think about me investing effort into trying to match into a good job, if there is a lot of uncertainty, I may exert less effort because of the same type of arguments I was mentioning before. That may be an explanation of why we are not in the place of the Beveridge curve, or a part of the explanation of why we are not there. And that's kind of an interesting line of research and everything related with human capital. Now, let me conclude since I'm running out of time. I think that what I want you to take away from this paper is the likelihood function is really telling you there is a lot of evidence that if you want to fit the data, these innovations to volatility matter a lot. If you take a standard business cycle model, you fit those innovations to volatility, you are going to get very interesting action. And of course, many things left open. For someone who is smarter and knows more economics than I do, I think that thinking about all the political economic equilibrium implications of this thing will be very interesting, and trying to open the black box of why we have those volatility shocks. Thank you.